Hello ladies and gentlemen, this is Dr. Me at the Actual Academy again, and we have a problem where at a given school 70% of the students like rock music, 30% like rock music and country music, and 15% like neither rock music nor country music. And we'd like to find the probability that a randomly selected student likes rock music or country music but not both. Now, we're going to need a few facts that I have listed here to solve this problem. First one involves what's called De Morgan's laws. Now, you don't really necessarily need to know these laws by its formal name. As a matter of fact, you can intuit your way through these fairly easily. So if you have two events, A and B, and you union them, their complement is actually equal to A complement intersect B complement. Now if you draw a Venn diagram, you can see why this is true, and this is very helpful in manipulating events to get them in a form that's easier to work with sometime. So for this problem we will actually use number 1. However, for other problems, the second fact is useful and good to know. That is, A intersect B complement is equivalent to A complement union B complement. So again, it's sometimes useful to manipulate these operations to get them in a form that might be more manageable for a given problem. And fact 2, we see this one a lot. The probability of the complement of an event is equal to 1 minus the probability of that event. So I'm going to first lay out some notation. We will define the event R as likes rock music. Likewise, we're going to define the event C as likes country music. So some items that are given to us, I'll put that up here, based on our newly defined events, is that the probability of liking rock music, okay, we get that right here. They express it as a percent. We'll convert it to a decimal, so it looks more like a probability, 0.7. We also have that the probability that a student likes rock music and country music is 0.30. Okay, we get that from this statement here. And we also have the probability that they do not like rock and they do not like country, so they like neither, is given as 0.15. So it's important to take what's given to you in English and convert it to some form of mathematical notation. That makes the problem easier to solve. Okay, so that's what's given to us, and we want to find the following. The probability that a randomly selected student likes rock music or country music, but not both. So in terms of the notation we have listed here, that is, we want to find the probability that they like rock music and do not like country music, or they do not like rock music but they like country music. Now I'm actually going to use a Venn diagram to solve this. Obviously on an actual exam they don't really care how you solve it as long as you're not cheating, but you can use anything at your disposal to solve this. So if it makes it easier to say use a Venn diagram and it's very clear from the Venn diagram, then go ahead and use that avenue. And I'm going to convince you that what looks rather complicated here is actually equal to the probability of liking rock music or country music minus the probability that they actually like both, because we actually want to subtract that back out. So I think you can convince yourself that this is equal to that. But so just to emphasize, I'm going to draw a Venn diagram to illustrate this concept a little further. So we have an event that denotes the people that like rock music, and another event, those students that like country music. And what we want to find is the probability that someone likes rock music but not country music. So let's shade that in here in red. So here, this event R denotes those students who like rock music, but we do not want to include those that also like country music. We want to exclude those. So this is R intersect C complement. and we need to union that with people that do not like rock music, but they do like country music. So what I'm shading in red here is the event for which we want to find the probability. So this piece here is actually colored in red. Let me also illustrate this piece here. This in the middle here is the intersection of R and C. So this piece here denotes R intersect C. So we really don't want that piece in our calculation. And as you see here, we're going to end up subtracting that out. So that piece is in blue, and that's going to be indicated by this, and I'll just informally denote that way. So what we're left with is R union C. So R union C is everything that's blue and red. So as you can see from the picture, it's pretty clear. We'll take the union of R and C, which will happen to include those that like rock and country music. With the understanding that we've included those, we just subtract those back out here, and then we're left with the answer. Okay, so what we're given here is the probability that a student does not like rock music and does not like country music. Now this looks suspiciously familiar to De Morgan's first law here, where we have A complement intersect B complement, and we can rewrite that as, in terms of this notation, as R union C, those who like rock or country complement. That's what we'll do right now. Okay, this was the application of De Morgan's law here. This looks a little bit more manageable, and we can even take it one step further by using fact 2 here. This is equal to 1 minus probability of R union C. But we know what that's equal to. This is given to us as 0.15 here. So now we can actually solve for this piece here, probability of rock or country, and that implies that probability of liking rock or country is equal to 1 minus 0.15, which is equal to 0.85. And we're already given the probability of R intersect C, that's this middle piece here. That was actually given to us in the problem statement right here. So let's just, for completeness, reproduce that here. The probability of R intersect C is equal to 0.30. So now we really have all the pieces. We have this one, probability of R union C, 0.85, and we have the probability of R intersect C, which is 0.30. And we're done with a final answer of 0.55, or 55%. And that's our answer. Thank you very much.